Hello and welcome. This video will try to solve problems of this kind, square root of quadratic functions. I'll tell you the procedure to do it. First, let us check. We have to check whether the roots exist or not. Here we have a is equal to 1, b is equal to 5, and c is equal to 6. So let's find the discriminant. Discriminant d is equal to b square minus 4ac. This we all know. b square is 25 minus 4 into a is 1 into 6. So 25 minus 24, which is 1, which is greater than or equal to 0. So it means real root exists. So once we know the real roots exist, let us find the roots. If you find the roots, you get x square plus 5x plus 6, x square plus 3x plus 2x plus 6. Take x common, x plus 3 plus 2 common, x plus 3. So this is x plus 2 times x plus 3. So x is equal to minus 2 and x is equal to minus 3 are the roots. So what I can write is f of x is equal to square root of x plus 2 and x plus 3. As I told you in the last video, the curve will cuts x-axis at minus 2 and minus 3. So to find the domain of this function, square root this entire thing should be greater than 0. So let us take in the number line to find the domain. Let us take minus 3 here and minus 2. So this is not needed more anymore. See, here we have to see where the domain exists. Let us take, you take anything less than minus 3. Anything less than minus 3, let us put minus 4. If you put minus 4, this becomes minus 4 plus 2, minus 4 plus 3. So minus 4 plus 2 is minus 2, minus 4 plus 3 is minus 1. Both are negative. So this will give you positive. So anything you take below minus 3, both x plus 2 and x plus 3 are negative. And if you take greater than minus 2, let's take minus 1. We take x is equal to minus 1. So you'll get minus 1 plus 2, minus 1 plus 3, which is 1 and 2, both are positive. So from this region, after minus 2, both x plus 2 and x plus 3 is positive. So positive into positive is positive, so square root of positive does exist. If you take anything between minus 3 and minus 2, let's take minus 2.5. If you take minus 2.5, let's see what happens. If you take minus 2.5, this is minus 2.5 plus 2, this is minus 2.5 plus 3, so this is minus 0.5 and this is plus 0.5. So one is positive, one is negative, so you get a negative value here. So any value you take between minus 3 and minus 2 will give you a negative answer. So negative of square root does not exist. So this will not come under the domain. So the domain of this function, always remember, if it has roots, the domain of this function is minus infinity to minus 3 included union minus 2 comma infinity. So minus 3 is included because if you put minus 3, minus 3 is included because when you put x is equal to minus 3, this becomes 0. Square root of 0 does exist. Square root of 0 is 0. So minus 2 If you put minus 2 also, you get square root of minus 0. Square root of minus 2 plus 2 is 0. So square root of 0 does exist, so minus 2 is included. So this is the domain. So whenever the curve touches x-axis, the range of quadratic function under the square root is 0 to infinity. It actually goes like this, 0 to infinity, right? So let us solve another problem to understand it better. So here I have x square plus 2x plus 6. Let us find the discriminant d. D is b square minus 4ac. b square is 2 square minus 4 into 1 into 6, which is 4 minus 24, which is minus 20. So d is less than 0, so it is negative. So in this case, no real roots exist. No real roots exist. So whenever there is no real root exist, the curve would simply look like this. It goes like this. So here we need not to find the domain particularly, because any value of r, any value of x will not produce undefined object. So the domain is complete real number, which is r. So when the domain is completely real number and the curve is looking up, we have to find the f minimum. So we know that for ranges f minimum is included, f minimum to infinity. So how to find f minimum is square root of minus b square by 4a plus c comma infinity. So let us find minus b square by 4a plus c separately. Minus 2 square divided by 4 plus c is 6. So minus 4 by 4 plus 6, which is minus 1 plus 6, which is 5. So range of this function is root 5. So this value is 5, root 5 to infinity. So we can verify this on the graph plotter. X square square root of x square plus 2x plus 3. So I told you, if there are no real roots, this is what you get. So root 5, 1.414, is it 2x plus 3? We took 2x plus 6, sorry. So we have to take 2x plus 6. 2x plus 6 is 2.236. I think it should be root 5. Let's check with the calculator. What is root 5? Square root of 5 is 2.236. That's what we got. Let's move on to the next problem. X square plus 2x. So f of x, I can write this as x into x plus 2. So here the roots are x is equal to 0 and x is equal to minus 2. So directly we'll write without wasting much time. So if I write the number line like this, we have 0 over here and minus 2 over here. Let us extend this. So anything between minus infinity to plus 2, minus infinity to minus 2, both these terms are negative. So you will get positive value of the product. From here to here, both are positive. So I'll get positive. Here you get negative value, the product negative. So the domain is minus infinity to minus 2 included, union 0 to infinity. And the range is whenever it touches the x-axis, always it goes like this. So the range is 0 to infinity. 0 to infinity. We can check this. We can check the range and domain. X square plus 2x, you can see. Is it x square plus 2x? Yeah, x square plus 2x, as you can see, minus 2 to minus 2 to 0, we don't have the domain. Next, move on to the next problem. X square plus 9. Let us try to find the roots of this. F of x is equal to square root of x square plus 9. What we have to do whenever we have square root of quadratic function, we have to check whether the roots exist or not. That is the main thing here. So a is 1, b is 0, c is 9, b square minus 4ac. The discriminant is 0 minus 4 into 1 into 9, which is minus 36. So no real root exists. It means you can put any value to x, any values of x, we won't get a negative value here. So in such cases, the domain is complete real number. Range for this is, since a is positive, the curve will be up looking like this. We have to find the minimum point, f minimum. Range is from f minimum to infinity. F minimum I can find as square root of minus b square by 4a plus c comma infinity. B is 0, so this complete term is 0. Square root of c is 9 to infinity. So this I claim as the range is 3 to infinity. Let us check in our graph. X square plus 9. X square plus 9, you can see the graph goes from 3 to infinity. Let's move on to the next problem. This is over. X square minus 9, f of x square root of, I think the root exists here, you get x plus 3 into x minus 3. Root exists means it touches the x-axis. So at x is equal to minus 3 and x is equal to plus 3. So the range, domain, we can, let's directly write the domain. The domain as minus infinity to the smallest root. Smallest root is minus 3 included, and from 3 to infinity we have domain. And the range, if it touches x-axis, the range is 0 to infinity. 0 to infinity, or you can write r plus. Let's move on to the next problem. So now this is an interesting problem. This is a down looking curve like this. Let us check the roots of this. The roots are, I'll take the roots, x square minus x square plus 5x plus 6. You can check whether the roots exist or not. Like discriminant is b square minus 4ac. B square is 25 minus 4 into a is minus 1 and 6, which is 25 plus 24, which is 49. So greater than 0, real root exists. So it touches x-axis. It does not go below x-axis. So what are the roots? X square plus 5x minus, so we'll write x square plus 6x minus 1x plus 6. We'll take minus x common, we'll get x minus x minus 1 x minus 6. This is minus x minus 1 and x minus 6. This I can write as f of x as, so the roots are minus x is equal to -1 and x is equal to +6 are the roots. F of x, I can write it as minus of x plus 1 and x plus x minus 6. So now if I bring the number line over here, the roots are -1, -1 and 6. So if I take anything below minus 1, let's take -2. If I take -2, what I get is minus of -2 plus 1, -2 minus 6. So this one minus of -1 and -8. So negative into negative into negative. So anything here you get negative. The product will be negative. Then after 6, if I take, let's take 7. If I take 7, I take 7, I take 7, minus of 7 plus 1, 7 minus 1. So minus of 8 into 6. So because of this negative, the whole product is negative. So here also you will get negative. So what if I take anything between -1 and 6? So I'll take, let's say, 5. 5. If I take 5, you'll get 5 plus 1, 5 minus 6. So minus of 6 minus 1. So this becomes positive. Only here it is positive. So our domain, as I told earlier, if the curve is down looking, the domain is between the roots. The domain is between the roots. Both the roots are included. And the curve would look like this. That ends the maximum value somewhere here. Let's find the maximum also. So domain I can write as -1 comma 6. Let us find the range. The range is f max square root of f max comma 0. Square root of f max, let's find minus b square by 4a plus c somewhere here. Minus b square, b is 5, b is 5. So minus 25, b square is 25, divided by 4a, 4 into -1 plus 6. So this is minus 25 by -4 plus 6, which is 25 by 4 plus 6, and further I can write this as 25 plus 24 divided by 4, which is 49 by 4. 49 by 4. So my range will be square root of 49 by 4 comma 0, which is 7 by 2 comma 0, or this is 3.5 comma 0. Let us verify in the graph. Minus x square plus 5x plus 6. So maximum point is 3.5. Yeah, got it, up to 0. Move on to the next problem. So now this is fairly easy to do because I can directly find the roots. If x is equal to square root of, if I take minus x out, I'll get x minus 5. So the roots are x is equal to 0 and x is equal to 5. Domain I can directly write, since the curve is looking down, the domain should be between 0 and 5, between the roots 0 and 5. Range, since it is looking down, the range is square root of b square minus b square by 4a plus c to 0. Since b is 0, here a is -1, b is 5, sorry, c is 0. So let us find minus b square by 4a plus c minus 5 square divided by 4 into -1 plus c is 0. So this is minus 25 by -4, which is 25 by 4. 25 by 4 is 4 4, 6 are 24, 6.25. So the range I claim is 6.25 to 0. Let us verify. Minus x square plus 5x. So this value should be okay. So it has to come under square root. This is so we're doing the same mistakes again and again. Square root of 25 by 4 comma 0. This is equal to 5 by 2 comma 0, which is 2.5 comma 0. This is my range. So this is 2.5 to 0. Let's move on to the next problem. F of x is 9 minus x square. I can write f of x as square root of 3 square minus x square, square root of 3 plus x and 3 minus x. This implies x is equal to minus 3 and x is equal to plus 3 are the roots. The domain for this function is, since the curve is looking down, you can see negative x square we have. So domain is from minus 3 to plus 3. Range is, since it is looking down, square root of minus b square by 4a plus c comma 0. Here minus x square plus 9 is the equation. A is minus 1, b is 0, c is 9. So b square minus b square by 4a is this term because 0. Square root of c comma 0. Square root of c is 9. Square root of c, square root of 9. So the range is 3 to 0. So let us verify this. Square root of 9 minus x square. So it is 3 to 0. Minus 9 minus x square. So f of x is equal to square root of, if I take minus out, I'll get 9 plus x square. So here you put whatever value to this is completely positive. Any value of x, even if you put negative values, this is positive because we have x square and plus 9. So this positive times negative, it is always negative. So you won't get f of x square root of positive value. So you won't get. So domain does not exist for this function. Domain does not exist for this function. Since domain doesn't exist, range also doesn't exist. In the next videos we'll solve some more problems. Thank you.